Hello, I am Dr. Sigarkanti. In this video, we discuss even and odd function, the product of even and odd functions, and finding a naught, an, bn, if the function is even function or odd function, and finding the Fourier series for even function and odd function. So first of all, what is a even function and what is odd function? Okay, so here a function f of x is said to be even function. F of x is said to be even function if f of minus x is equal to f of x. If f of minus x equal to f x, then you say that it is a even function. For example, f of x is equal to say x square. F of x equal to x square. Then what about f of minus x? Replacing x by minus x, we write here minus x square, but minus x square is same as x square. This is nothing but f of x. So that is here we are getting f of minus x is equal to fx. Therefore, the function f of x equal to x square is even function. Similarly, we can consider f of x is equal to x to the power of 6. Then what about f of minus x? This is equal to minus x to the power of 6. As the power 6 is even here, this is nothing but minus 1 to the power of 6 is plus 1 itself. This is nothing but x to the power of 6. This is equal to f of x. So therefore here f of x is equal to x to the power of 6 is also even function. That is, any even power of x is always a even function. And if we consider say cos of f of x equal to say cos x, then what about f of minus x? Replacing x by minus x, we get here cos of minus x. But what is cos of minus x? This lies in the fourth quadrant. In the fourth quadrant, cos is positive. So that is cos of minus x equal to cos of x. This is nothing but f of x. So therefore here cos x is even function. Cos x is even function. Next we define odd function. So that is here a function f of x is said to be odd function if f of minus x is equal to minus f of x. Okay, if f of minus x is minus fx, then you say that it is a odd function. For example, I will consider example f of x is equal to say x cube. I will take f of x equal to x cube. Then replacing x by minus x, we get here f of minus x equal to minus x whole cube. Minus x whole cube is nothing but minus of x cube. This is equal to minus x cube is nothing but f of x. So here we are getting f of minus x is equal to minus fx. So therefore here f of x equal to x cube is odd function. This is a odd function. And similarly, if we take f of x is equal to sine of x, then what about f of minus x? This is sine of minus x. And we know that sine of minus theta is minus sine theta. This is minus sine of x. This is equal to minus. What is sine of x? It is nothing but f of x here. So that is we are getting f of minus x is equal to minus fx. So therefore sine x is odd function. Okay, sin x is odd function, cos x is even function, sin x is odd function. Okay, so that is a function f of x is said to be even function if f of minus x equal to fx. For example, x square is even function, x power of 6 is even function, and cos x is even function. And here, by replacing x by minus x, if the sign of the function changes, then you say that it is odd function. That is, if f of minus x equal to minus fx, then you say that it is an odd function. For example, x cube is an odd function because here we have f of minus x is equal to minus fx. And similarly, any odd power you can take, they are all odd functions. And here we have a trigonometric function f of x equal to sin x is a function here. If we replace x by minus x, f of minus x equal to sin of minus x. Sin of minus x is nothing but minus sin x. This is equal to minus sin x is fx. So that is f of minus x is equal to minus fx. Therefore, we say that sin x is odd function. Okay. Now we consider the product of even function, odd functions, and so on. Now here we consider product of even and odd functions. Product of even and odd functions. First I will consider both even, next even odd, next I will consider odd even, then I will consider odd odd. Okay, so here number 1, let fx even and gx is also even. Okay, f of x is even, g of x is even. Then what this implies here is f of minus x is equal to f of x and g of minus x is equal to g of x. Now here let me consider the product of these two. So that is here let h of x is equal to f of x into g of x. I am considering the product of the two even functions. Now if I replace x by minus x, what I am getting here is h of minus x is equal to f of minus x into g of minus x. This is equal to f of minus x is fx, g of minus x is gx. So that is I am getting fx into gx. This is nothing but h of x. So I am getting here h of minus x equal to h of x. So this implies h of x is even function. Okay, even function. So that is even function into even function is again a even function. Okay, next I will consider to let fx is even and gx is odd. Then fx is even means f of minus x equal to f of x and g of minus x equal to, as gx is odd function, this is equal to minus g of x. Okay, now h of x, I have taken h of x is equal to fx into gx. H of minus x, consider we have h of x, we have taken this as f of x into g of x. Now if I replace x by minus x here, then h of minus x is equal to f of minus x, g of minus x. This is equal to, here f of x is even function, therefore f of minus x is just fx into g of x is odd function, therefore g of minus x is minus g of x. So this is equal to minus of f of x into g of x, this is equal to minus h of x. So that is what I am getting here is h of minus x equal to minus hx. What this implies? This implies hx is odd function because I am getting h of minus x is equal to minus hx, therefore h of x is odd function. So here I have taken f of x is even and g of x is odd function. What I am getting here is this is odd function. So first case even into even is even and second case even into odd function is odd function. Next I will go to third one. Let f of x is odd function and g of x is even function. Now f of x is odd function means f of minus x is equal to minus fx and g of x is even function means g of minus x is equal to plus g of x. G of minus x equal to g of x itself. Now here h of minus x, where hx is equal to fx into gx. This is equal to f of minus x into g of minus x. This is equal to f of minus x. As if f of x is odd function, f of minus x is minus fx and g of minus x is just g of x. So this is equal to minus fx into gx. This is nothing but our h of x. So here we have h of x, we have taken this as f of x into g of x. Okay. So here I am getting h of minus x equal to minus hx. That means here h is odd function here. That is here h of x is odd function. What I have taken here is I have taken fx as odd function into gx even function even. This product I am getting as odd function. Next case I will consider let fx is odd and g of x is also odd function. Then if f of x is odd, then f of minus x is equal to minus fx and g of x is also odd. That means g of minus x is equal to minus g of x. Okay. And here we have, let me take h of x is equal to f of x into g of x. If I replace x by minus x, I will write this as h of minus x is f of minus x into g of minus x. This is equal to, what is f of minus x in this case? It is minus fx into, what is g of x? G of minus x? G of minus x is also minus gx. This is minus g of x. So this is equal to minus into minus plus. Okay, this is plus f of x into g of x. This is nothing but h of x. So that is here h of minus x. H of minus x is equal to h of x. What this gives? This implies h of x is even function. So that is here I have considered here is f of x is odd function, g of x is also odd function, but the product I am getting as even function. So that is if f of x and g of x are any two functions, then we have even into even is always a even function. Even into odd is odd function. Odd into even is again a odd function. Odd into odd, we are getting this as even function. Okay. If both even or both odd, then their product is always even. Otherwise, that is one even, one odd. Then we get the product is odd function. Okay. Next we go to see here we have some properties of integration for even function and odd function. From the definite integral property, if f of x is even, then integral minus a to plus a f of x dx can be written as 2 times 0 to a f of x dx. This is one property. And if f of x is odd, then minus a to integration minus a to plus a f of x dx is equal to 0. So that is, we can write like this: minus a to plus a f of x dx is equal to, this is equal to 2 times 0 to a fx dx if f is even, and it is equal to 0 if f is odd function. Okay. Now if I consider a function here, say f of x is equal to x square plus x, fx equal to x square plus x. Is this even function or odd function? Let me verify. F of minus x is equal to minus x square, replace x by minus x here, plus minus x, this is equal to minus x square is same as x square, plus into minus minus x. Now this is neither equal to f of x nor equal to minus f of x. Okay, that means here this function is neither a even function nor a odd function. This is neither even nor odd function. This is some other function. Now, if the given function is even or the given function is odd, then how to find the values of a0, an, bn for Fourier series? Okay, so here we have Fourier series is f of x equal to a0 by 2 plus summation n from 1 to infinity f of x into cos of n pi x by l dx, n pi x by l plus summation n from 1 to infinity bn into sine of n pi x by l. Suppose the function is even function or odd function, and if it is defined in the interval minus pi to plus pi, so that is here, let fx be periodic function with period 2 pi, and defined in minus pi plus pi. Okay, minus pi plus pi. Now first I will consider, let f of x be even function. F of x be even function. If f of x is even, then we have a0 equal to, as the function is defined in this interval minus pi to plus pi, that is a equal to minus pi and l equal to plus pi. This is equal to 1 by l, 1 by pi, and this is a minus pi to plus pi, a equal to minus pi and L is equal to plus pi. Okay. So 1 by pi into minus pi to plus pi f of x into dx. This is equal to. So I have taken in minus pi to plus pi. You can take in minus L to plus L. Okay. Now this is equal to, see here, this integration is of the form minus a2 plus a fx dx. And if f of x is even function, then we have, by the property of definite integral, this can be written as 2 times 0 to a. Therefore, this is equal to 2 by pi into 0 to a is this pi here, f of x into dx. Okay, this is the value of ya naught. And what is an? An is equal to 1 by L 1 by pi, a to a plus 2L, a equal to minus pi here, a plus 2L becomes pi, and here f of x into cos of nx dx. Here L equal to pi, therefore this becomes just cos of nx. Now, what is the fx here? In this case, we have taken fx is even. So f of x is even. What is cos function, trigonometric cos? This is also even. Fx is even, cos is even, therefore even into even is again even. If this is even function, then minus pi to plus pi can be written as 2 times 0 to pi. So therefore, this is equal to 2 by pi into 0 to pi f of x into cos nx dx. This is our an. An can be obtained by this. And what about bn? So here bn is equal to, we have the formula 1 by L 1 by pi into minus pi 2 plus pi f of x into sine of nx dx, because L equal to pi. Now here fx is even function. What is sine? Sine is odd function. Even into odd is odd. So therefore, this is whole thing is odd function. If this is odd function, then by the property of definite integral, minus a2 plus a odd function, its value is 0. So therefore, bn becomes 0. So this is equal to 0. Okay. So that is here bn equal to 0. So we have got, so that means here finally conclusion is, if f of x is even, then f of x is equal to a naught by 2 plus summation n from 1 to infinity an into cos nx plus, here we have in this case bn equal to 0. Therefore, this is our Fourier series, where a naught is given by 2 by pi 0 to pi fx dx, and an is equal to 2 by pi 0 to pi integral 0 to pi f of x into cos nx dx, and here we have bn equal to 0. Okay, if f of x is even function, then a naught equal to 2 by pi 0 to pi fx dx, an equal to 2 by pi 0 to pi fx into cos nx dx, bn equal to 0, and fx is given by this thing. Now next we consider if the same interval, if f of x is odd function, if f of x is odd function, then we have a naught equal to 1 by pi minus pi to plus pi f of x dx. This is equal to, directly we can write 0 because fx is odd function. Then what about an? An is equal to 1 by pi minus pi to plus pi f of x into cos of nx dx. This is equal to, see here, fx is odd function and cos is even function. Odd into even is odd function. If this is odd function, then this value equal to 0. So therefore, this an value is equal to 0. And bn is equal to 1 by pi minus pi to plus pi f of x into sin of nx dx. This is equal to, see here, f of x is odd function. Sin is also odd function. Odd into odd is even function. If this becomes even function, then the value of the integral is 2 times 0 to pi. Therefore, bn is equal to 2 by pi 0 to pi f of x into sin of nx dx. Okay. So therefore, if f of x is odd, then immediately we can write a naught equal to an equal to 0 and bn equal to 2 by pi 0 to pi f of x into sin nx dx, and f of x is equal to just summation n from 1 to infinity bn into sin of nx dx. So that is if the function is even function or odd function, then using these, if the function is even function, then bn equal to 0, we can find out a naught and an. If the function is odd function, then both a naught and an equal to 0. Just we have to find out the value of bn. Okay. Okay, thank you. I will stop here.